Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 17, that is a network database architecture, that is the chapter number 17. In the last class we have finished with the chapter number 17, and today I am going to start with the chapter number 18, that is the parallel system. But before this, let's take a quick review what we have covered in the last class. So in the last class we have discussed about the interconnection of the network, that is how different networks are interconnected with each other, that is how they communicate with each other, how different computers will communicate with each other, that is the interconnection of the network. So parallel system consists of a set of computers. So there are multiple computers that is available that can communicate with each other via an interconnection network. So they can interconnect, or different computers can communicate with each other with the help of the interconnecting network. Figure 7.7 shows three commonly used type of network. These three types of networks are as follows, that is a bus, mesh, and the hypercube. That is, a bus is a serial line, mesh is within the square, different computers are attached. Then there will be hypercube that is available, that is there are different multiple parts that is available in the hypercube, that is the interconnection networks. Then there will be a parallel database architecture. We have discussed that is what is the database architecture. That is a parallel database architecture in which the architecture in which the database or in which the systems are connected with each other in a parallel form. That is, there are different parallel machines that is available. So there will be architecture that maintains the parallelism. That is, one task will be available in more than one systems. That is a parallel database architecture. So there will be a shared memory, shared disk, shared nothing, hierarchical. That is, in the parallel system, these are the four methods. These are the four, we can say, the ways by which we can parallelly maintain the database. That is a shared memory, shared disk, shared nothing, and the hierarchical. Then there will be a shared memory, what we have covered. That is what is a shared memory. That is, more than one processor uses the same memory, that is known as the shared memory, so that they communicate with each other through a communication, also an interconnection channel or network. That is a shared memory architecture. Shared memory architecture usually have large memory caches at each processor, so that referencing of the shared memory is avoided whenever possible. So whenever we want to refer any shared memory that is available, we avoid them whenever there will be a possible, that is a shared memory. And there will be a shared disk. That is, in a shared disk model, all the processors can access all the disks directly via an interconnection network. They are available, or they get the disk by an interconnected network that is available, but the processors have a private memories. Then we have discussed about the shared nothing. That is, in this system, each node of the machine consists of a processor, memory, and one or more disks. That is, each node is available, each mode is available, that consists of a processor, memory, and one or the more disks. That is a shared nothing system. Then hierarchical system, that is available, that combines the characteristics of the shared memory, shared disk, and the shared nothing architecture. These are the combination, or hierarchical architecture is a combination of all the three methods, that is a shared memory, shared capacity, there will be a shared data, or shared nothing that is available. Then we have discussed about the distributed system, that is how distributed system works and what are the main advantages of distributed system. The main advantage is that the same task will be distributed among the various concern, among the various flows, so that it will be available whenever there will be a need of the data. So if any system fails, so there will be no loss of the data that is available, that is distributed among the various data. So computers are distributed, or computers in a distributed system are referred by a number of different names, such as the sites or the nodes. So there are different nodes, there are different sites that is available, that are known as the sites or the nodes, depending on the context in which they are mentioned. And the main difference between the shared nothing parallel system and the distributed system are that distributed system are typically geographically separated. So they are geographically separated with each other, and are separated, administered, and have a slower interconnection rate that is available in the database connectivity. And there will be a local transaction, that is the one that accesses the data only from the site when the transactions was initiated, and the global transaction means that is either the data will be available, either the transaction will be initiated or access the data in several different ways. This is the distributed system. There is a site A, there is a site C, there is a site B, and site A will be communicated with the site B. There are two arrows, that is site B also communicate with A also communicate with B. And there are several reasons for building the distributed database system, including the sharing of data, autonomy, and the availability. So first one is the sharing data. That is, in a distributed system, the data will be shared among various computers, among various networks. Then autonomy, that is a distributed system is available to retain the degree of control over the data, that is the autonomy. Then there will be availability, that is the data is available. If one of the sites fails, the data is available at the from the different sites. Then this is the example, this is a banking example, that is how the database or distributed system works, how one account will be debited from to credit the another account. Then what are the, we have discussed what are the various implementation issues that is available. So the main concern is that there will be a two-phase commit protocol, that is a 2PC is the most widely used of these protocols. And the main idea behind 2PC is for each side to execute the transaction until it enters the partially committed state and leave the commit decision to a single coordinator size. And another issue that is available in the distributed system database is that there will be a concurrency control. That is another issue, that there will be no control of the concurrency. So that is a major issue that is also available in the distributed database systems. And when the task is to be carried out are the complex, involving multiple databases or multiple interaction with humans, coordination of the task and the ensuring transaction properties for the task become more complicated. So whenever there will be more tasks, whenever there will be more data, so that task will be complicated, and that task will not work in a proper or in an efficient manner. So then we have discussed about the network types. So there are mainly three types or two types of network that is discussed over here, that is the LAN and the WAN. And the main difference is that in the LAN there is a local area network. Every computer is attached, every network is formed within the geographical boundary. That is, data will be available or data is sent between the geographical boundary, that is within the country, within the domain, or within the geographical boundary. And wide area network means beyond the geographical boundary, anyone can send the data, anyone can receive the data beyond the geographical boundary. That is a WAN, that is a wide area network. So there is a LAN, that is a local area network. There is a WAN, that is a wide area network. The main difference between the two is the way in which they are distributed geographically. So it is a main difference is that in which, or the way in which they are distributed geographically. In local area networks, processors are distributed over smaller geographical areas, such as a single building or a number of adjacent buildings. So in a local area, for example, if I am working in an organization that is a Mercury Solutions, so in this there will be a network that is known as the local area network. This is the gateway, these are the application server, workstation, workstation. Then local area network, that is also used to share the data among each other. Then in storage area network, that is a special type of high-speed local area network that is designed to connect large banks of storage devices to computer that uses the data. So whatever the data that is available, that will be available to the computer to use the data. Then there will be a wide area network that is emerged in the late 1960s mainly for the academic research project to provide the efficient communication among the sites. That is, these boundaries are available or network is formed beyond the geographical boundary, and there is no foundation that the communication will be made within the geographical boundary. No, but the communication will also be made after the or beyond the geographical boundary. The best example is internet. And there are two types of WAN that is available. One is the discontinuous connection, one is a continuous connection. For example, when you talk about the wireless, that is a discontinuous connection. When you talk about the wired connection, that is a continuous connection. Then there will be a summary, that is the summary of this chapter, what we have covered in this chapter. That is the first point is the centralized database, then servers, what is the difference between the parallel system, distributed system, local area network, and the storage area network or wide area network. Now let's start with the today's session, that is the today's topic, that is chapter number 18, that is the parallel databases. That is what is the parallel databases, how to use the parallel databases. So in this chapter we discuss fundamental algorithm for the parallel database system. That is, what are the various fundamental algorithms that is available for the parallel database system that are based on the relational data model, and we mainly focus on the multiple disks that is available in the distributed system, that is available in the parallel evaluation of the relational operations, both of which are instrumental in the success of the parallel databases. So how the data will be available, how data will be accessed among each other. That is the main case or that is the main issues that is available in the parallel processing or parallel database. So let's start with the introduction, that is introduction to the parallel system. At one point over 2 decades ago, parallel database systems has been nearly written off, even by some of the advocates that is available. But now, today, they are successfully marketed by practically every database system vendor. That is, they are practically approached, they are practically getted by every database system vendor. Several trends fuel this transaction. That is, there are multiple trends that is available in fuel these transactions. The first point is that says the transaction requirements of organizations have grown with increasing use of computers. So whenever there will be a transaction requirement, whenever there will be a transaction approach that will be used, that has been grown with the increasing use of the computer. That is the first point. That is, there will be more requirement for the use of the computers in the database system. The next line says, moreover, the growth of the www has created many sites with millions of viewers, and the increasing amount of data collected from these viewers has produced extremely large database at many companies. That is, more and more data will be available from the transactions, from the databases, from the internet, and they are created many sites with millions of viewers, and there will be a large amount of data that is collected from these viewers to maintain the large databases at many companies and many areas. Then next point says, organizations are using these increasingly large volume of data, such as data about what items people buy, what web links users click on, and when people make telephone call. So whatever the organization, whatever the data that is available, that is used to store large amount of data to plan on the activities and the pricings. And the queries that is used for such purposes are known as the decision support queries. So whatever the query that is available, that is a decision support queries, and the data requirement for such queries may run into the terabytes. So what is the requirement that is available in the terabytes? Single processor systems are not capable of handling such volume or large volume of data at the required rate. So whatever the single processor data that is available, they are not available at the, or they are not capable of handling the large amount of or large volume of data at the required rates. The set-oriented nature of database queries naturally lends to itself to parallelism. So whatever the query that is available, that lends to the parallelism, and a number of commercial and research systems have demonstrated the power and scalability of parallel query processing. So whatever the query, whatever the parallel processing that is available, that will be available in the database systems. As microprocessor has become cheap, parallel processing has been common and relatively, because before our days there are many processors that is available, there are many CPUs that is available, that is in cost range, or that is a costly. But nowadays microprocessors are cheap, so parallel machines have become common and relatively inexpensive. Then individual processors have themselves become parallel machines using micro or multi-core architectures. So as we discussed in chapter 17, parallelism is used to provide speed up, where queries are executed faster because more resources such as the processor and the disk are provided. So parallelism is a way to provide the speed up, that is it is a way to provide the speed up, that is the data is available or the processing is done in a very fast speed, where queries are executed faster because more resources such as the processor and the disk are provided. Parallelism is also used to provide scale up, where increasing workloads are handled without increased response time via an increase in the degree of the parallelism. So there are different architecture that is available for the parallel databases. Like shared memory, shared disk, shared nothing, hierarchical architecture. Briefly, in the shared memory architecture, all the processor shares a common memory. That is, every processor that is in the parallel processing uses the same processor, uses the same CPU, or uses the same memory. But shared disk in nothing, or in nothing architecture that is available, processors share neither memory nor the disk. That is, in a share nothing, there is no sharing neither the memory neither the disk. But in the shared disk, the memory and the disk are, we can say, they are maintained or they are shared among each other. And in the hierarchical architecture, every node that shares neither memory nor the disk with each other, but internally each node has a shared memory or a shared disk architecture. Then next is the input-output parallelism. That is, what is the input-output parallelism that is available? So in its simplest form, input-output parallelism refers to reducing the time that is required to retrieve relations from disk by partitioning the relations over multiple disks. So input-output parallelism, that means reducing the time required. So whatever the time required that is used, so that is reducing the time required to retrieve the relation from the disk by partitioning the relations over multiple disks. The most common form of data partitioning that is available in a parallel database environment is horizontal partitioning. So this is the most common form of data partitioning that is available, that is a horizontal partitioning. In horizontal partitioning, whatever the tuples of the relation, whatever the rows of the relation are divided among various disks, and each tuple resides on each disk. So whatever the disk that is available, each tuple have each disk, or each tuple have one disk that is available. That is the input-output parallelism. That is, the input is also given in the parallel and the output is also given in the parallel. Then what are the various partitioning techniques that is available? So we present three basic data partitioning strategies that is available. Assumes there are n disks that is used, that is D1, D0, D1, Dn-1 across which data to be partitioned. So these are the various partitioning techniques, how the data will be partitioned, how the disk will be partitioned among each other. That is the data partitioning. So first partitioning technique that is available is a round robin method. So this strategy scans the relation in any order. That is, round robin means either go from the left hand side, either go from the right hand side. So this scans the relation in any order and sends the ith tuple to the disk number di mod n. So this is the round robin means it will be rotated in a circular way, one to the another to the one, and so on, so on, so on. That is the round robin method. This strategy, this method scans the relation in any order and sends the ith tuple to the disk number di mod n. The round robin scheme ensures an even distribution of tuples across the disk. That means there will be a fair distribution of the disk among, or fair distribution of the tuples among the various disks. That is, each disk has approximately the same number of tuples as the others. Then next partitioning technique is the hash partitioning. So whatever the clustering, whatever the strategies that is used, that will be available from the given relation as in the partitioning attribute. A hash function is chosen whose range is 0, 1, n minus 1, and each tuple of the original relation is hashed on the partitioning attribute. Then there will be a range partitioning. So one is a hash partitioning, then next is a range partitioning that divides the tuple among the various ranges. That is, there are different range that is available, that is a range partitioning. It chooses a partitioning attribute A and a partitioning vector such that the if I is less than j, then Vi is also less than Vj, and the relation is partitioned as follows. This is one of the example. That is how the relation, or how the data will be, or the relation will be partitioned among each other. The next is the comparison of the partitioning technique. That is, what are the various techniques that is available and how to compare the partitioning techniques. Once a relation has been partitioned among several disks. So once a relation, or once a table can be, or once a table has been partitioned among various disks, among various criteria, we can retrieve it in parallel. So we can retrieve the data in a parallel form using all the disks. Similarly, when a relation is being partitioned, it can be written to the multiple disks in parallel that is available. Therefore, the transfer rates for reading or writing an entire relation are much faster with input-output parallelism than without it. So whenever we transfer the data, whatever the transfer rate that is available for reading or writing the entire relation are much faster with input-output parallelism than without it. So whenever we use the parallel system, the input-output processing, input-output data is more secure, or we can say the more faster than the underlying unnecessary data. However, reading an entire relation or scanning a relation is only one kind of access to the data. Access to data can be classified as follows. So what are the various accesses by which we can access the data? That is as follows. First of all, scan the entire relation. That is how to access. So first of all, scan the database, or scan the entire relation, scan the entire table. Then locating a tuple associatively, that is locating the table, locating the row associatively, that is how they are associated with each other. These queries, known as the point queries, seek tuples that have a specified value for a specific attribute. So whatever the specific attribute that is available, whatever the tuple that is available, they are used for a specific attribute. Then locating all tuples for which the value of a given attribute lies within the specified range. So whatever the tuple that is available, whatever the range that is available, that is given or that is taken for a given attributes, that lies within the specified range. For example, if I want to find the salary between the 1000 and the 2000, these queries are known as the range queries. One is a point query that is only pointing out something, that is employee name equals to Campbell. Then range queries, that is given the range that is between 1000 and the 2000. The different partitioning technique that is available that support these types of access at different levels of efficiency. So there are different partitioning techniques that is available that supports these types of access, or that support multiple access at a different level of efficiency. So one is the round robin, that is automatically, or that is generally used or suited for the application that wish to read the entire relation sequentially for each query. Round robin means that is best suitable for the various techniques that is used to read the data, read the entire relation, read the entire table in a sequence manner. Because that is a round robin means the data will be available, that data will be searched in a sequence way, then again go back to search with another way, and so on. In a hash partitioning, that is best suited for the point queries, that is best suited for point queries, that is what is a point query or what is the main target, that is a employee name equals to Ram, employee name equals to Harry, employee name equals to Campbell, any name that is a point to the specified person, that is a hash, that is used in the hash partitioning. Then there will be a range partitioning, that there will be a range that is given, that is a range partitioning that is used. An advantage of this feature is that if there are only a few tuples in the queried or queried range, then the query is typically sent to the one disk as opposed to all the disks. Whatever the type of partitioning that is available, that also affects other relational operations such as joins, as we see in the 18.5. Then handling of the skew, that is how to handle the various skews that is available in the database system. So when a relation is partitioned, there may be a skew in the distribution of the tuple. So the relation is partitioned among multiple forms. So the relation, or there may be a skew in the distribution of the tuples with a high percentage of tuples placed in some partition. So there will be a high range of tuple that is used in some partition that is used in the database architecture, and the fewer tuples in other relations. The ways that skews may appear are classified as. So these are the two types of skews that is available. One is the attribute value skew, one is the partition skew. So attribute value skew, that refers to the fact that some values appears in the partitioning attribute of many tuples. That is, there are some values that is available that appears in the partitioning attribute that is available in the that is of multiple attributes of many tuples. That is the attribute value skew. All the tuples with the same value for the partitioning attributes end up in the same partition, resulting in the skew. And the partition skew refers to the fact that there may be a load imbalance in the partitioning even when there is no attribute queue. So partitioning queue means the partitioning the queue, that will be a load imbalance that is available in the partitioning even when there is no attribute skew. Attribute value skew can result in the skewed partitioning regardless of whether range partitioning or hash partitioning is used. So whatever the partitioning is used, it may be used, that may be a range partitioning, that may be a hash partitioning. And partition skew is less likely with the hash partitioning if the good hash function is chosen. So more and more hash partitioning is used, and the less partition skew is used, because if I want to use a good hash function that is chosen, so partitioning or the partition skew is very less as compared to the hash partitioning. And there will be a balanced range partitioning sector, that is a vector, that is also constructed by sorting method. So there are different method that is used, or that is used for the sorting on the partitioning attributes. The input-output overhead for constructing balanced range partition vector can be reduced by constructing and storing a frequency table or the histogram. So that will be a range partitioning vector that can be reduced by constructing and storing the frequency table or the histogram that is used, that is available in the database architecture. Another approach to minimize the effect of skew, particularly with range partitioning, is to use virtual processors. So another approach that is used to minimize the effect of the skew that is available, that is used with the virtual processors. And in the virtual processor approach, we pretend that there are several times as many virtual processors as the number of real processors. The idea is that even if one range has many or has many more tuple than the other because of the skew, these tuple will get split into the multiple virtual processor that is used for the different processor. These are the various histogram, that is how to divide the same transaction into the multiple bars. Now next is the interquery parallelism, that is how the parallelism will be maintained within the interquery. The interquery means within the query there will be a parallelism that is available. So in interquery parallelism, different queries or transactions executes in parallel. So different transactions can execute in the parallel system, can execute in the um, modified system with one another. Transaction throughput can be increased by this form of parallelism. So whatever the transaction throughput, that is a result that will be increased or that can be increased by this form of parallelism that is available, that is the interquery parallelism. So throughput means the output or the display that is used in the transaction processing parallelism. Therefore, the primary use of interquery parallelism is to scale up a transaction processing system to support a large number of transactions per second. So whatever the transaction that is used, whatever the data that will be used, that is used to available, or that is used to get the data that is available in the transaction processing. So transactions which are operated in a time shared concurrent manner or a sequential machine operate in a parallel in the shared memory parallel architecture. And there will be a problem that is used with this later version is the cache coherency control. So there will be a cache coherency control, that is how to control the cache memory. And various protocols are available to guarantee cache concurrency. So there are multiple protocols that is used to control various concurrency or coherency that is used. So that is a coherency protocol that is used to get the data available. This protocol ensures that when a transaction sets a shared or exclusive lock on the page, it gets the correct copy of the page. So whenever we set the shared or the exclusive lock on the page, it gets the correct copy of the page. And more complex protocol avoids the repeated reading and writing to disk required by the preceding protocol. And such protocol do not write pages to the disk when exclusive locks are released. When a shared or exclusive lock is obtained, if the most recent version of a page is in the buffer pool of the same processor, the page is obtained from here. Then there will be an intra-query parallelism, that is execution of one query, single query in parallel on multiple processor, and that is the same query is available on the multiple processor, same query is available on the different processor, different tasks, different, we can say the CPUs and the different disk, the same query, that is a single query. Using intra-query parallelism is important for speeding up the long running queries. So whenever we use the intra-query parallelism, that is most important to speed up the long running queries. That is, if there are more than one query that is available, that is a long running means the time is more required in the queries processing, that is a long running queries, that is very suitable for the intra-query parallelism. That does not help in the task since each query is run sequentially. And to illustrate the parallel evaluation of a query, consider a query that requires a relation to be sorted. So whatever the relation that is used, that can be sorted with each other. In summary, the execution of a single query can be parallelized in two different ways. So there will be execution of the query that will be used, that is available in the two different ways. That is the inter-operation parallelism, there will be inter-operation parallelism. That is how to use the inter or intra-operation, that is how intra-operation means how different operation will be performed within a parallelism, and inter means within the copy that will be used in the operating parallelism. Next is the intra-operation parallelism, that is how to use the intra-operation parallelism. I'm just coming within 2 minutes. So next is the intra-operation parallelism, that is how to maintain the intra-operation, that is within the or we can say that between different operations there will be a parallelism, that is the intra-operation parallelism. Since the relation operations works on a relation, so there are many relational operations that is works on the operation that is less than, greater than, that containing large set of tuples. We can parallelize the operations by executing them in the parallel. So there are multiple operations, we can execute that operation, that is the same greater than, the same less than sign, that is executed in the parallel on the different subsets of the relation. And since the number of tuples in a relation can be large, so there will be a more relation, there will be a more parallelism that is available, that is potentially enormous. Therefore, the intra-operation parallelism is natural in the database system. So whatever the operation that is used, that is whatever the data that will be used, that is naturally in the database system. We shall study parallel version of the some common relational operation in section 18.5.1 and 3. So first is the parallel sorting, that is the sorting will be available in a parallel way, that is sort the various days, that is the end days, that is a D0, D1, Dn minus 1, that is partition, or that is a range partition on the attributes on which it is to be sorted. And we can sort the each partition in a separate way. So we can sort the partitions in a different way, in a different manner. And if the relation has a partition in any other way, we can sort it in one of the two ways. So what are the two ways? We can range a partition it on the sort attributes, and we can use the parallel versions of the external sort merge algorithm. The next is the range partitioning sort, that is the range partitioning sort that works in the two steps. What are the various steps that is used in range partitioning sort that works in the two steps? First, range partitioning the relation. So first of all, there will be a range. The range partitioning the relation, that means the range will be partitioned, that is used for the various relation that will be used for the various tables. Then sorting each partition separately. So whatever the sorting mechanism that is used, that will be sorting the relation that is used. When we sort by range partitioning the relation, it is not necessary to range partitioning the relation on the same set of the processor or the same set is not used on the different processor as those on the that relation is stored. And there are two steps that is involved in this operation, that is how to apply the range partitioning sort. First one is redistribute the tuples in the relation. So first of all, redistribute the tuples, whatever the tuples, or how many tuples are available, that is available in the relation using a range partitioning strategies, so that the all tuples that lie in the range can be used with the processor. Then each of the processor sorts is partitioned in a different way. Then next is the external sort merge, that is how the sorting will be done in the external. So that is the alternative approach to the range partitioning. So we can either use the sort partitioning, external sort merge, or either we can use the range partitioning. Suppose that a relation has been partitioned among the various days. So suppose there is a relation that is used, there is a table that is used, that is partitioned into various days, that is a D0, D1, Dn minus 1, that is partition will be sorted. So the parallel external sort merge then works in this way. And each processor, that is a PI, locally sorts the data on the disk DI. And the system merges the sorted runs on each processor to get the final stored output. So whenever we merge the various runs, whenever we merge the various parallelism that will be used, there will be a various sequence of the action that will be used. The system range partitions the sorted partitions at each processor, that is a PI, across the processor P0, P1 until Pm minus 1. Then there will be a parallel join, that is there will be a join operation that will be used, that the system uses a test pair of the tuples to see whether they satisfy the join operation or not. So there will be parallel join, that means how they join, how they interact with each other, that is finding out the tuple to see whether they satisfy the join operation or not. If they do so, the system adds the pair to the join output. So whatever the join output that is available, they can pair the data, they can pair the output that is available in the join operation. And the parallel join algorithm attempts to seek out the data, attempts to find out the data, that is what data is available, to find out the data that is available. There will be a parallel join, then there will be a partition join, that is a partitioning will be formed to make the join operation, that is a partition join. So partition join works in the same way, that is that positions the relation R and set the relation in each of the four relations that will be available, that is denoted by the R0, R1 and Rn minus 1. The system sends the partitioned Ry Si to the processor Pi, where they can join in a computed manner. So they joined in the computed manner in which they are executed. So the partition techniques work correctly if the join is equi-join. So if the join that is used is a equi-join, so the partition will work in the efficient manner. So there will be a range partitioning on the join attribute, there will be hash partitioning on the join attributes. Then there will be a fragment and the replicate join, that is how to fragment, or when first of all there will be a fragmentation, then there will be a join operation. So first of all divide them, and then the replicate join operation will be formed. The general case of the fragment in the replicate join appears in the figure 18.3.b. So this is the 18.3.b that is used, that is how to perform the join operation and how to fragment the join operations. So choose the database that is occurred, that is available. So there will be a relation that is maintained. So if the size of the S is less than that of the R, the parallel has join algorithm that proceeds in this way. These are the various mechanisms how the join operation will be used. Then the parallel nested loop join, that is how to use the parallel nested join loop. That is what are the various scenarios in using the parallel nested join loops. So to illustrate the use of fragment and the replica based parallelism, consider the case where the relation S is much smaller than the relation R. Suppose the relation R is stored by the partitioning, so the attribute that is available, that does not matter. Suppose that there is an index on a join operation of relation R at each of the partition of the relation. We use asymmetric fragment and replicate with relation S being replicated and with the existing partitioning of the relation R. Now each processor Pi performs an index nested loop join of relation S with the ith partition of relation R. The next is the other relational operation, that is what are the various other relational operations that will be used, that is used in the parallelism. First is the selection, that is first of all selection will be maintained to maintain the parallelism. Then there will be a duplicate elimination. Then there will be a projection, that is without duplicate elimination the projection will be maintained. Then there will be aggregation, that is the aggregation means use the aggregation groupingism that is used. Then what are the various costs that is available for the proper evaluation of the operation? One is the startup cost, one is the skew cost, one is the contention for the resources, then cost of the assembly. So these are the various costs that is used in the this is intra-parallel operations, or we can say the inter-operation parallelism. Now next is the intra-operation parallelism, that is within the outside the operation that is used. Let's take a break right now, then move to this topic, that is the intra or inter-operation parallelism. So let's take a break right now. So next is the come back from the break. Now let's start the session again. Next is the inter-operation parallelism, that is how to maintain the or how to perform the inter-parallel parallelism. So there are two parts of inter-operation parallelism. One is a pipeline parallelism, one is the independent parallelism. That pipeline means the parallelism will be maintained in the pipeline one after the another, that is a pipeline parallelism. Independent parallelism means there will be independent parallelism, there is no interfere between no interfere among the various databases, that is the independent parallelism. So first is the pipeline parallelism. So as discussed in chapter number 12, pipelining forms an important source of economy of computation for database query processing. So whatever the pipelining that is used as an important source of economy that is used for the database query processing. Recall that in pipelining, the output tuples of one relation, that is A, are consumed by the second operation B even before the first operation has been occupied. So that means different transactions are executed in a different manner, that is they are executed in a pipeline, that is the one after the another. That is, if one is finished, another will be produced, another is finished, third will be produced, and so on till next transaction will be performed in a parallel. The parallel system, the major advantage that is used in the parallel execution in a sequential evaluation is that we can carry out a sequence of such operations without writing any of the intermediate results out to the disk. So there is no need to write the result into the disk, intermediate result to the disk. Parallel systems use pipelining primarily for the reasons that sequential systems do. So what is the reason that is used in the pipelining? That is the main reason is that that sequential system must do, that is the parallel systems use the pipelining. However, pipelines are a source of parallelism as well. In the same way, instruction pipelines are a source of the parallelism in hardware design. So in the hardware design, it is also used, the parallelism is also used in the various designing part. And suppose A consumes B, B consumes A, so A is producing them, so that is the parallelism, that is they are also used in the pipeline parallelism. Then there will be independent parallelism, that is how to use the independent parallelism. So consider the operation that is used in the query processing that do not depend on one another, that can be executed in the parallel. So whatever the transaction, whatever the operation that is used in the query processing that do not depends on one another, that can be executed in the parallel. So they are executed in a parallel processing, and this kind of parallelism is known as the independent parallelism. So whatever the parallelism, whatever the content that is used, that is known as the independent parallelism. So consider the join, that is R1 is joined with the R2, then R2 is joined with the R3, and R3 is joined with the R4. So clearly we can compute that temp1, that is R1 is produced with the R2 in parallel with temp2, that is R3 is joined with the R4. When these two computations complete, we can compute, or we compute that temp1 is joined with the temp2. To obtain the further parallelism, we can pipeline the tuples in temp1 and the temp2 into the computation of the temp1, temp2, which itself carried out by the pipeline join operation, that will be carried out for the pipeline join operation, that is the independent parallelism. Like pipeline parallelism, independent parallelism is also used, that must provide a degree of parallelism. Then next is the query optimization, that is how to optimize the query, what are the various techniques to optimize the query. So query optimizers account in large measures for a successful relational technology that is used in the query optimizations. So recall that a query optimizer takes a query and finds the cheapest execution plan among the many possible execution plans that gives the same answer. So whatever the query optimizers that is used in the large measures for the successful relational technology that is used. And recall that the query optimizer takes a query and find out the cheapest execution plan. So what is the cheapest execution plan that is used among the various possible execution plans that gives the same answer number, or that gives the same answer. Query optimizers for a parallel query evaluation are more complicated than the query optimizers for the sequential query optimization technique. So whatever the query optimizers that is used, whatever the query that is used, that are more complicated than the query optimizer for the sequential query evaluation. The first one is that the cost models are more complicated since partitioning costs have been accounted for and issues such as the skew and the resource contention. So whatever the resource contention that is used the partitioning costs that have been accounted into the account. And the most important issue that is used in the parallel processing is the how to, or what is the main method, what is the main motto, or what is the main criteria how to parallelize a query. That is how to maintain the query in a parallel processing. Suppose that we have some show or somehow chosen an account, chosen an expression that is used for the evaluating the query. The expression that can be represented in the query that is used. So how to evaluate an operator tree in a parallel system, we can make the following decision. So when to evaluate the expression in a parallel system, we can, or we must make the following decision that is used in the operator tree. That is how to parallelize each operation. What is the main method, or what is the main motto, what is the main method, that is how to parallelize the operation, and how many processes to use for it. That is how many processes are used for the parallelism, how many content will be used for the parallelism for each operation. The next point, or the next content decision will be what operation do pipeline, or what operations pipeline, or do pipeline across different processors. That is, what are the various operations that will be operate in the various operations. These decisions constitutes the task of scheduling the execution tree. So whatever the execution tree that is used, whenever we schedule the execution tree, that is one after the another that will be executed. So the decisions also constitute the task of scheduling the execution tree, that is how to execute the execution tree. And determine the resources of each kind, such as the processor, disk, and the memory that should be allocated to each operation in the tree is an important aspect of the optimization problem that will be used in the optimization technique. And the advantage of using the parallelism that is used is negotiated by the overhead of the communication. And one concern is that long pipeline do not link and themselves to a good resource utilization, that is not used in the database architecture. Now, how to design the parallel system? What are the various concerns that is used in the parallel system? So what are the various issues, that is, what are the various concerns that is available in the parallel processing? So the next is how to design, or what are the various design issue of the parallel system, that is the design of the parallel systems. So whenever we design the parallel system that is available, so we can design them, and the parallelism of the database is also used for the query processing, that is how to maintain the data storage and how to process the query. That is the more concentration is on the data storage and the query processing. Since large-scale parallel database systems are used primarily for storing the large volume data and for processing decision support queries on those data, these topics are the most important in the parallel database system, that is storing large volume data, processing decision support system. Parallel loading of data from external sources is an important requirement if we are to handle large volume of data, large volume of incoming data. So whenever we use the parallel loading of the data from the external sources, that is very important in case if it is an important requirement if we process the data, if we are to handle large volume of incoming data. A large parallel database system must also address these availability issues. These are the availability issues that is used with the large parallel database system. First is the resilience to the failure of some processor or the disk. So that means it is residual to the failure of the processor or the disk. Then online recognition or online reorganization of the data and the schema changes. So whatever the schema changes, whatever the data changes, whatever the output changes that is available, that is the online reorganization of the data and the schema changes. We consider these issues here, that is whenever there will be a large number of system, large number of processor and the disk, the probability is that at least one processor or the disk will malfunction is significantly greater than a single processor system with one disk. So if there is any failure malfunctioning in one disk, so there are multiple other disks or the multiple other processor that is also available for handle such malfunctioning data. A poorly designed parallel system will stop the functioning of any component. So if there is a poor design parallelism that is available, so they stop the working, they stop the functioning if any component fails. Assuming that the probability of a failure of a single processor or the disk is small. So whatever the probability of the failure of the single processor, that is a small, and the probability of the system that goes up to linearly with the number of processor and the disk. And it will fail once every 5 years. A system with 100 processor and will have a failure every 18 days. Therefore, large-scale parallel systems such as the Teradata and the IBM Informix XPS are designed to operate even if the processor fails. So these are the various companies, these are the various processor that is used. These are the various database system, parallel database system that is used whenever our database fails. Or when we are dealing with a large volume of data with some operations such as the indices and changes to schema such as adding a column, so it can take the more time. So it is unacceptable for the database system to be unavailable while such operations are in progress. And most of the database system allow such operation to be performed online. That is, they are available online, they are used in the online method. That is, while the system is executing the other transactions. And for example, consider the example that is the online index construction that supports the feature for the insertions, for the deletions, for the updates on the relation even if the index is not maintained. So this is the online index construction that is used that supports the features for insertions, deletion, updates in the relation even as the index is maintained. In recent years, a number of companies have developed new parallel database products including the Netezza, Data that is used by the Microsoft and the Extra Data. Netezza, Greenplum and the Extra Data uses Postgres SQL that are underlying databases that is used the underlying database system but moved to a SQL server subsequent to its execution by Microsoft. That is used. It is also worth mentioning that the Netezza and the Data actually sells the data warehouse to the appliance, which includes the hardware and the software, allowing the customer to build the parallel databases with minimum cost. So these are the various software that is used to sell the data with the various warehouses that is used with the various appliances. Right. Now next is the parallelism on the multi-core processor. That is, what is the parallelism or how to provide the parallelism on the multiple processors. So if there are multiple processor, then till now we have studied how to use the parallel processing, how to apply the, or how to, what is the main advantage of parallel processing with single processor. But now how to use the parallelism within the multiple processor. That is, there are more than one processor and that processors are also used in the parallel. That is the parallelism on the multi-core processors. So let's stop over here only. this topic, that is the parallelism on the multiple processor, I'm going to start in the next class, that is in the tomorrow's class. That's all for today's session. Thank you so much everyone for listening me. Bye bye everyone.